Hey there! Sorry again I'm not here today, but I know you guys can do this, especially because it's not really different than last night's work. And you guys loved last night's work. Sorry if I'm a little out of it. It is now almost 6 o'clock and I'm about to go downstairs and hang out with your parents. Good times till 8 p.m. But here we go. First problem wants us to graph it, pretty much the same as yesterday. I just want you to add on this little thing of whether or not it's up and down, whether or not it's skinny or fat. Just like the absolute values, if this number's bigger than 1, then it gets skinny. If this number's a fraction, like 1/2, something smaller than 1, 1/3, then it gets wider, fatter. The U either bows out if it's a fraction, or it gets really skinny if it's a bigger number. And just like an absolute value, if it's positive, it goes up and makes a U. And if it's negative, it makes kind of like a lowercase n. Alright, so looking at this one, all you have to do is -7 tells us that we're looking for the point 7 to the right. And the -1, keep it sign, goes down 1. That means that we have our axis of symmetry at the point x equals 7. We have our intercept at 7, -1. Since 3, the coefficient here, is positive, it goes upward, like it faces up, like a U. And since 3 is a lot bigger than 1, it's pretty skinny. 3 times as skinny. And that is good enough. Right, we'll get into the intricacies of being extremely accurate on these graphs step by step, but for right now, you get the direction, whether it's skinny or fat, you know the axis of symmetry, and you know the vertex, we are solid. Vertex here, axis of symmetry, x equals 7. Alright, we're going to jump right into the next one from your homework, which is number 15. Alright, and number 15, pretty similar, except we're going to add on one more little step, and that is, what are the x-intercepts? Now, an x-intercept, by definition, is where it hits the x-axis. Where it hits the x-axis. Anywhere on this x-axis, be it here, or here, or here, what is the y value? Tim, I'm asking you what the y value. Good job, Tim. Yeah, it's 0. We haven't moved off the x-axis, so the y value is 0. The x-intercepts are where y is 0. Look at this equation. It's all multiplication. So if we could make any of these terms 0, the whole thing would be 0, and y would equal 0. What's a number I could put right here that I could add to 2, and the overall value would be 0? What can I add to 2 to get the value 0? -2. When I plug in -2, -2 plus 2 is 0, times 3 is 0, times whatever this is 0. So I know that -2, 0, because that's what y would be, is one of our points. Okay? I also know by that logic that -6 has to be one of our points. -6, 0. 3, 4, 5, 6. And since those are both on the x-axis and they have to be symmetrical, our axis of symmetry has to be halfway in between. Right here, halfway in between. What's halfway in between -2 and -6? Why, it's a -1, 2, 3, 4. So x equals -4 is our axis of symmetry. We have a point at -2, 0. We have a, at -2, 0. We have a point at -6, 0. One of the last things we have to do is figure out what the vertex would be. But we know the vertex is going to be on the axis of symmetry. Since the vertex has to be on the axis of symmetry, we know that the x value of the vertex has to be 4. So we're going to plug in 4 every time we see -4. Every time we see an x in our original equation, we're going to put in -4, because that's our axis of symmetry. -1, 2, 3, 4. -4 here, negative 4 here. That gets me y equals 3 times negative 4 plus 2 is negative 2. Negative 4 plus 6 is positive 2. Y equals 3 times negative 2 times positive 2 is negative 4, which equals negative 12. So we have x equals negative 1, 2, 3, 4. We have negative 4. Negative 4, negative 12. Here I thought I made a mistake, and it makes perfect sense. So we have to go down negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there is our vertex. It's at the point negative 4, negative 12. Here's our vertex. It's way more fun if you make that sound as you draw the U's. And there you have your U. Right? We have an axis of symmetry. X equals negative 4. We have a vertex, negative 4, negative 12, and we have our zeros, or our x-intercepts, at negative 6, 0, negative 2, 0. The last thing that's in your homework is they might ask you to take an equation like this and put it in standard form. Standard form is where you have an x squared and an x term. So in the interest of time, let's just do it with this equation. Y equals 3x plus 2 times x plus 6. In order to put that into standard form, and this is actually harder than any of the ones on your homework, I believe, but in order to put that into standard form, you just multiply it out. Keep in mind that multiplying two binomials means that you have to multiply 1, 2, 3, 4 times. We say the first one, the outsides, the insides, the last one's foiling. You might have heard of this. So y equals 3 times, I'm going to say, let's keep it all in parentheses for now because the 3, x times x, x squared. X times positive 6 plus 6x. 2 times x plus 2x. 2 times 6 plus 12. Y equals 3 times, now we have to combine those middle terms because they're two x terms. So x squared, 6x plus 2x plus 8x plus 12. Okay, lastly we're going to multiply by 3. Y equals 3x squared plus 24x plus 36, and there you have it in standard form. Hope you enjoyed. Don't freak out too much. We'll come back on Wednesday. I'll answer any questions you have, and then Thursday we're going to do a review worksheet. So catch you right up if you're a little bit confused. All right, folks, gonna miss you. See you on Wednesday. Be good.